Modern-day IoT. IoT, Internet of Things, is a rapidly growing field that involves connecting a wide range of devices and sensors to the Internet and enabling them to communicate with each other and with cloud-based applications. Here are some examples of modern-day IoT applications. 1. Smart homes. IoT-enabled devices such as smart thermostats, lighting systems, security cameras, and voice assistants can be used to control and automate various aspects of the home. 1. Homeowners can remotely control their appliances, turn off lights, and adjust the temperature using their smartphones. 2. Industrial automation. IoT can be used to monitor and control industrial processes, reduce downtime, and improve efficiency. 2. For example, sensors can be used to monitor the performance of machines and predict maintenance needs. 2. This can help reduce repair costs and increase uptime. 3. Smart cities. IoT can be used to manage traffic flow, reduce energy consumption, and improve public safety. 3. For example, sensors can be used to detect air quality, noise levels, and temperature, and adjust lighting and heating accordingly. 4. This can help reduce energy consumption and improve the quality of life in urban areas. 4. Healthcare. IoT can be used to monitor patients remotely, improve medication adherence, and enable telemedicine. 4. For example, wearable devices can be used to monitor vital signs and alert healthcare providers in case of any abnormalities. 4. This can help reduce hospital readmissions and improve patient outcomes. 5. Agriculture. IoT can be used to monitor crops, soil moisture, and temperature. 5. This can help farmers optimize irrigation and fertilizer usage, and increase crop yields. 6. Retail. IoT can be used to improve the customer experience by providing personalized recommendations and offers. 6. For example, beacons can be used to track customers' location within a store and provide targeted offers based on their purchase history. M2M, machine-to-machine. M2M, machine-to-machine, communication refers to direct communication between two or more devices without human intervention. In M2M communication, devices are connected to each other and can share data and information automatically, enabling them to work together to perform a task or accomplish a goal. M2M communication is commonly used in industries such as transportation, logistics, and manufacturing, where it is used to track and monitor assets, manage inventory, and automate processes. Some examples of M2M communication include: 1. Fleet management. M2M communication can be used to track and monitor vehicles, enabling fleet managers to optimize routes, reduce fuel consumption, and improve driver safety. 2. Smart grids. M2M communication can be used to monitor and control power generation and distribution, improving efficiency and reducing downtime. 3. Industrial automation. M2M communication can be used to automate manufacturing processes, reducing costs and improving efficiency. 4. Healthcare. M2M communication can be used to monitor patient health, enabling healthcare providers to remotely monitor patients and respond to emergencies quickly. 5. Environmental monitoring. M2M communication can be used to monitor environmental conditions, such as air quality, water quality, and weather conditions, enabling organizations to respond to natural disasters and environmental events quickly. IoT versus M2M. IoT, Internet of Things, and M2M, machine-to-machine, communication are related concepts, but they are not interchangeable. IoT refers to the concept of connecting everyday devices and objects to the Internet, enabling them to send and receive data and interact with each other and with humans. IoT devices are often equipped with sensors and can be remotely controlled, making them useful for a wide range of applications, from smart homes to industrial automation. M2M communication, on the other hand, refers specifically to the direct communication between two or more devices without human intervention. M2M communication is often used in industrial and enterprise applications, where it is used to automate processes, monitor and control equipment, and track assets. While M2M communication is a subset of IoT, IoT encompasses a broader range of devices and applications beyond just M2M communication. IoT devices can communicate with each other and with humans, using a range of communication protocols, such as Wi-Fi, Bluetooth, and cellular networks. In contrast, M2M communication relies solely on direct communication between devices. IoT versus WAT. IoT, Internet of Things, and WAT, Web of Things, are related but distinct concepts. IoT refers to the ecosystem of devices and applications that are connected to the Internet, enabling them to send and receive data and interact with each other and with humans. IoT devices are often equipped with sensors and can be remotely controlled, making them useful for a wide range of applications, from smart homes to industrial automation. WAT, on the other hand, is an extension of IoT that seeks to standardize the way devices are connected and interact with each other on the web. The goal of WAT is to make it easier for developers to build applications that can access and control devices across different platforms and vendors. WAT uses web technologies, such as RESTful APIs and HTTP, to provide a common language for devices to communicate with each other. While both IoT and WAT are focused on connecting devices to the Internet, WAT is more focused on standardization and interoperability, while IoT is more focused on the broad ecosystem of connected devices and applications. IoT Reference Architecture. IoT, Internet of Things, reference architecture is a blueprint or framework that defines the building blocks, components, and principles of a typical IoT system. The reference architecture provides a high-level overview of the IoT system and serves as a guide for designing and implementing IoT solutions. There are several IoT reference architectures available, but they typically include the following components. 1. Things, devices or objects that are connected to the Internet and can collect and transmit data. 2. Connectivity, the network infrastructure that connects the things to the Internet, including protocols such as Wi-Fi, Bluetooth, and cellular networks. 3. Data processing and analytics, the software and hardware infrastructure that processes the data collected by the things and provides analytics and insights. 4. Applications and services, the user-facing applications and services that enable humans to interact with the things and the data they collect. 5. Security and privacy, the measures and protocols that ensure the security and privacy of the data collected by the things and transmitted over the network. 6. Management and orchestration, the tools and processes for managing and monitoring the IoT system, including device management, software updates, and performance monitoring.